All right, welcome back, everybody. This is now 3:35. We were working on radicals and exponents, and maybe we should just do some more hard ones of those. Give you guys some practice. So let's see, let's come up with a good one. Well, that was pretty rough. Maybe not that rough. Let's go with this. Simplify. Let's do 25 to the 3 halves times 4 to the 3 halves. Nope, 5 halves. All divided by, let's go with 10 to the 3 halves. Times 2 squared on bottom like that. Hello. I have no idea what this is going to look like when it's done. This is what happens when you wing it. What?
So we're gonna find out together.
Right. Come back. Trouble's come back.
So Ross, hey, I had this is the name, Mr. You were his tutor, not his tutor, but you were in his class. I was in there with him.
I need more than that.
And I was saying Cactus though.
Hooray.
Nah,
Not Mr. Bray.
that's not super rare.
Mr. Birch, Mr. Tom, Mr. Blakely.
You work with a lot of people, huh?
There's about 15 math teachers.
Okay, yeah. Nice, pretty guy. And he does the coding class too.
Mr. Redden. It's got to be Mr. Redden.
I think there was a really kid that was had his coding class too. But, it was online, so you probably didn't.
No, didn't see a lot of faces online.
Yeah, I know. It's still fun, but let's see.
Let's see here.
So I'm calling every, okay, so I don't want to deviate, I brought you up, I'll work every day. One night, coworker, she said, like, David is one of the, Mr. Jones is really nice.
An icon. I don't know if I'm an icon. That sounds like
So
strange.
I feel like as far as like local math, those definitely are, you stick out.
Iconic though. I don't know. I like it. It sounds
Especially,
good.
You know, the 100%, especially like, I feel like in this week, for the pandemic, I feel like a lot of the professors. That is not the case.
That's true. That is
It's
true.
pretty iconic. So.
I don't know if iconic's the right word, but legendary, yes. Icon though, I don't know, kind of. I like it. Iconic is like the statue that's in front of the seal.
Watch that happen.
Icon's like a mascot. I could be a mascot.
Oh, I guess so, we're like, not like the face, so like, yeah, I don't know, I do know that you definitely like stick out.
Well, thank you. Did I make this too hard? We'll find out. How are you two doing online, Christopher and Erica?
I'm doing good. Yeah, I'm just still working on it.
Okay, good. So is every other student in the room. You're not alone. I kind of made it hard. That's good. Practice should be hard. If practice is hard, tests feel easy. That may sound like bullshit, but it's not. See if everyone's going, how you guys are doing. Start checking out what we can do. What do you guys, someone tell me what you started with. What approach did you take? We'll go that route.
Can you pencil out the 3 over 2? Or like, or no?
What do you mean?
Like, do they pencil out or do you wait another step for that?
Their exponents, we can't cancel them out unless they have the same base.
Okay.
So. One thing we can do is. With the 25 and 3/2. I can write that as 25 to the 1/2 cubed. And that's the square root of 25 cubed. So this is 5 cubed. And I'm just going to leave it as 5 cubed for now. I'm just going to clean up my radicals or my exponents that have fractions in them. See what I can do. On this one, the 4, we've got 4 to the 5/2, which is 4 to the 1/2 to the 5th power, which is the square root of 4 to the 5th power. Square root of 4 is 2, so this is 2 to the 5th power. That'll be that one. This one doesn't have a fraction exponent. I'm going to leave the 2 squared alone. 10 to the 3/2 doesn't really clean up a lot, other than maybe like I could write this as 10 times 10 to the 1/2. But I don't know if that really helps any, because that's like 10 root 10. That's not getting me anywhere. So another way of looking at it is going, okay, maybe 5 and 2 are multiples of 10. So maybe I should write the 10 and 3/2 as 5 times 2 to the 3/2. And then I can split that up. I can make 5 to the 3/2 and 2 to the 3/2. I'll do that. That is not, there we go, let me rewrite it. Okay, we can start, now that we have same bases on some of this stuff, we can start subtracting. I can do, this becomes 5 to the 3 minus 3 halves. This becomes, and I don't know how the math is gonna look when I do it, but the number on top, the exponent on top, I can subtract the exponents on bottom. Hello? Don't know what the hell that is. It's a healthcare rental equipment. It's gotta be for my mom, but there is no rental equipment left. They've already picked up everything, so I don't know what they're looking for. All right, so if I do 3 minus 3 halves, 3 is like the same thing as 6 over 2, that's 3. So if I do 6 halves minus 3 halves, I end up with 3 halves. So we just combine the numerators. So that'll be 5 to the 3 halves. If I do the 5 minus 2 first, if I change the order of this to be like that, 5 minus 2 is 3, and I've got 3 minus 3 halves. We just did that shit. So I'm not going to redo it. So now this is where we kind of want to like separate it out from, we don't want an improper fraction like that. So this is like, let's change colors again. 5 to the 1 plus 1 half. That's what 3 halves is, 1 and 1 half. And the same thing with that one, 1 plus 1 half. Which means I can write that as 5 to the first power times 5 to the 1 half. Times 2 to the first power times 2 to the 1 half. And 5 times 2 is 10. So I've got 10 times 10 to the 1 half, or 10 times the square root of 10. So there's a lot going on there. Just exactly where you end up. Hopefully it's down to something like one of these, or 10 to the 3 halves. 10 to the 3 halves works. A little messy. That's what I get for winging it. Any questions? You guys want some more clusterfuck math?
Yeah, we're gonna do more of these ones, right?
Yeah,
Oh, okay.
more practice with the exponents.
You didn't finish the whole fraction.
Yes, I did.
You don't you have to like factor out, not factor out, but like simplify what is on top and on bottom?
I did that with the subtracting of exponents.
You did. Never mind.
Good question though.
Because
Alright,
because
next.
I did it differently,
Did you end up with the same answer?
I think.
Or how did you do it? Let's explore other ways to do this.
So the top half of the fraction I left as its factors. So 5 times 5 times 5 times 2 times 2 times 2 times 2, 5 times.
Okay, and what'd you do with the 1 half and the exponents?
So
Oh, I see what you took the square root. So you had 5 times 5 times 5. That's the same thing as the 5 cubed into the power. Okay, what'd you do on the bottom?
So
That's the wrong
with the
thing.
10 to the 3/2, I took that, like you said, what that as it's the square root of 5 times 2 to the third power.
Square root of 5 times 2 to the third power.
No. Wouldn't both of them to be to the third power?
Well, if we break this up. Oh, I see what you're saying. Like. Are you saying like that?
Basically.
Okay,
But also you can distribute the 3 to each of the square roots, right?
right. Okay,
So then I
And we-
wrote them all. I wrote all those out, right? So square root of 5 times square root of 5 times square root of 5.
okay, let me get caught up with you.
Mhm.
And we still have the 2 squared, so
Yeah,
times 2 times 2. I'm just assuming you broke that up.
And the square root of 5 times the square root of 5 is 5, right?
That's a 5.
So I did that, and I did the same thing with the two of those.
Okay,
Yeah. And then I canceled all everything that could cancel out. So well, that leaves you with 5 times 5 times 2 times 2, which is 100 on top. And then the square root of 5 times the square root of 2, which I re-put, yeah, like that. Is that correct?
it is, it's just not simplified all the way.
Because that also equals 10 to the square root of 10.
It does,
Like-
it's, every step has been correct. We haven't really gone over what we do with radicals in the denominator yet, we're gonna do that today. So that is a good, you're good so far. We will cover how to go from here to the 10 root 10 later today.
Nice.
Actually, I'll give you a little primer of it now. We don't like leaving radicals in the denominator. So what we do is, well, we could do what we did above using these exponents, but another option is just multiply the denominator by the same radical. And if you do the denominator by it, you gotta do the top by it. So by that principle, we've got 100 times square root of 10 on top. And we're gonna do just as Chris was saying, square root of 10 times square root of 10. Square roots is like cancel each other out, we're just left with 10. So the bottom is 10. And then 100 divided by 10 is 10. You like that? How's that? That's awesome, wasn't it? Super cool. Now, this is entirely doable, it just takes a while. I'm not gonna say no to it. If you do this on like the test or something like that, go for it. I think you'll find yourself saving time if you learn how to deal with them as exponents. And then just do the exponent rules. But completely valid. Anybody else do anything different? I feel like my hair is gonna like have like electric shock. I feel it, it's just going all fucking fro on me, isn't it? All right, we'll let Senzi catch up, although we she just walked in.
Sorry. Thomas is sort of busy.
That's okay, I'll think of another I'll start setting up another problem while you're writing this out. There you go. That looks like fun. Are you done with the first page, Cincy?
Yes.
How you guys doing online?
I just
Good.
had sent you a message about it.
Oh. I'll leave the chat channel open. Okay. We'll go over it some more in a second. I don't know if since he's working or doodling. Are you working on this or doing something else? No, if you're still working, keep going. Okay. So. Just as a quick reminder, the rules of exponents. We have a to the m times a to the n. We can add them. If we have b to the m over b to the n, we treat them as subtraction. And then the one that's probably one more that's in there. A to the m to the n would be a to the m times n. But probably the one that's giving you guys the most struggle is dealing with the fractions and radicals and how they change between them. So if I got like, I'm going to use d for David. D to the m over n is a fraction. This effectively means the nth root of d to the m power. And we can also put the m to the outside. I can do the nth root of d to the m power like that. It's just what the notation means. That's how fractional exponents work. So they generate roots. So we're never going to have like n equals 1 doesn't make sense because there's no like one root. We always have like a square root or a cube root. The most common ones you'll see, n equals 2 or 3, are the most common ones because they're realistic in things in real life. Because it's based on square roots and cube roots. So like d to the 1/2 is the square root of d. D to the 1/3 is the cube root of d. And now I could write square root of d, or I could put like that. Put a little bit of line in there. When it's a 2, n equals 2 is the lowest one. So that's why we don't write it. On the radical sign. It's not wrong. Doing this is not wrong, but we tend to just do this. For the same reason, when we have like 5 to the first power, we just say 5. There's a default setting. When we're talking about positive numbers or negative numbers, positive is the default setting. So I don't have to say I have plus 3 apples. I just have 3 apples. And so negative is like, in that case, the term that gets all the explanation. So how does that apply to ours? Yeah, I was wondering if I erased that. Good. And so knowing stuff likes to cancel a lot. I try to like break things down to their smallest components first, their factors first. So 6 to the 3 halves is really just 2 times 3 to the 3 halves. And 8 is 2 to the 3rd power. And that's to the 1/2. Not a time equal sign times. That's just rewriting this 6 and this 8 up top without dealing with the fractions. And I'm going to do that down below too. 18 is 9 times 2. So I could say 9 to the 1/2 and 2 to the 1/2. I could even say 3 to the 1/2 times 3 to the 1/2 here. But remember, the 1/2 exponent means square root. And I already know what the square root of 9 is, so I'm not going to bother chopping it up anymore. I'm just going to leave it as 9 to the 1/2. The 4 is 2 squared. And then I still have the 3 halves. So that's my 4. Maybe if I had written this in the form 9 times 2 to the 1/2, it would look a little bit more like the 18 up there. And I should have done that. So now that I got that, let's see what I can do. I'm going to use this rule right here to kind of like move these exponents inwards. How's that work? Well, if I need to multiply something, this is like taking n here and multiplying it by n. So I need to do that here. I can take the 1/2 and multiply it by the 3. I can take the 3 halves and I got to multiply it by something. I don't see anything there though, so I'm going to put in a default 1. And I'll take that 3 halves and multiply it in there. So if I do that, I have 2 to the 3 halves times 3 to the 3 halves times 2 to the 3 halves again. I'm just going to rewrite the 9 to the 1/2 as a 3 right now. We already said it was the square root of 9. I'm going to do that. And here I've got 2 times 3 halves is just 3. So that's 2 cubed there. Give me a second to let that soak in. Okay, from here, what I'm going to do is I'm going to like combine things on the top and the bottom separately right now. I've got the 2 to the 3 halves and the 2 to the 3 halves on top. I can treat that as 2 to the 3 halves plus 3 halves. That's this rule right here. And I still have a 3 to the 3 halves. I can't do anything with that. On the bottom, I can't do anything with the 3, but I can add the 1/2 and the 3 there on the exponents for the 2. I'm going to have 3 plus 1/2.
And then you had gotten that 3 because 3 was the square root of 9.
Yes,
And you wouldn't multiply the 1.5 to the 9 to the 3 as well, only to the 2? Because are you multiplying both of the
I
numbers?
did the 1/2 times the 2 and the 1/2 times the 9. From the 18,
Mm-hmm.
oh, like right here. And that's what I did there. And the 9 to the 1/2 just becomes the 3,
Oh, okay.
and the 2 to the 1/2 is right there.
Oh, okay.
All good? On that part so far?
Yeah.
All right. So let's add those fractions together. I've got 3/2 plus 3/2 is 3. And you know what? I'll just leave that as a mixed fraction right there. 2 to the 3.5. Now I'm gonna do the subtraction rule. I'm gonna do this thing right here with the b to the m over b to the n. Anything that has the same base, I'm gonna subtract exponents. So with the 2, I have a 3 on top, and I have a 3 1/2 on bottom. And then for the 3, I have 3/2 on top. And then just a 1 on bottom. Since it doesn't show a number, it's just a 1. So if I do that subtraction, I've got 2 to the negative 1/2 and 3 to the 1/2. Negative fractions, exponents, we should move to the opposite side of the fraction. So the 3 to the 1/2 is going to stay on top. The 2 to the negative 1/2 moves to the bottom of the exponent or the fraction, and it makes the exponent positive. So this is like the square root of 3 over the square root of 2. We haven't covered it in the main class yet, but if we want to clean it up with what I was saying earlier, we don't want a radical on the bottom. So what we're going to do is we're going to multiply the bottom by the same radical it already has. And on top, I get square root of 2 times square root of 3 is square root of 6. And on bottom, I get square root of 2 times square root of 2 is 2. So that would be a good answer, or you could write 1/2 times the square root of 6. Either of those works. Any questions? We're doing a lot more stuff with radicals today. As I proceed to torture the shit out of you guys. It's almost 3 o'clock though, so we'll take a break. Stop the video at 3:35.